Right. Okay. All right, so it is 2 o'clock. The plan is to is for me to start getting grading done this weekend. That's my plan for the weekend. I'm planning on meeting with your TAs on Saturday evening so that we can get started grading together, and then from there they will grade their appropriate sections. If you feel that a TA or I have graded something unfairly, then please bring it up to me, up with me, you know. It helps sometimes to know what your thought process behind a question was or behind your answer. Now we have spring break upcoming. Now, I'm not feeling burnt out, but boy, do I feel like that spring break is nice and positioned to help us from being burnt out. So, and if you feel overworked or really busy with your stuff, please let me know so that I can get a good grasp of how swamped you are if I need to pull back on what we're doing. But like today. So for instance, today is one of those days where I have an exercise scheduled, or an exercise kind of planned, and I still plan on doing quite a bit of it. But I got a number of emails either saying, hey, so got a number of things about Lab Form 5. Demos from multiple students who didn't have functions working in their program. A number of questions about if they could have an extension, or they were having issues with a problem. So I figured I'd go over at least the multiplication table from homework 4 and 5, just to go over that and show a couple different ways to slice that one. The other thing about that is that if you're going to have any questions about Lab 4 and 5, I'll try my best to answer them, without necessarily giving the answer away for those. In addition, I have what used to be like the homework that I gave. I used to make Lab 4 and Lab 5 like separate things, but it worked out to do Lab 4 and 5 as one big assignment. And as a result, I dropped a couple of questions from there. So I've got, as an in-class exercise, some of the questions that we previously went over, I've used previously as homework. The difference between these ones is that the ones I give for Lab 4 and 5, they involve you needing to print things or to move the turtle. Whereas the exercises on the PDF I have linked for today, those exercises ask you to return something. So, but let's talk about the multiplication table from Lab 4 and 5. So Lab 4 and 5, we ask you to produce a multiplication table that looks something like this, but a bit prettier. By multiplication table, I mean here 2, 4, 6, 8, 10, and then let's see, so 5 by 5, so 3, 6, 9, 12, and then as you can see, it gets a bit uneven here, 15, right, and so on and so forth, right? So we ask you to produce these things. So this is a bit of a tricky problem for multiple reasons. First, we ask you to produce a table, which necessitates a loop. In fact, a nested loop, most likely. Okay. So so that becomes a bit tricky. The second thing is formatting. And the third thing is the fact that I ask you to put it to do a function, right? So I ask you to produce an n by n table, which I find a bit easier to do than telling you to have, in other words, a square table rather than something rectangular shape. I find that a bit easier to not have to worry about multiple dimensions. So the way we start anything that has a function like this is I start by writing the function. I don't generally, as a rule, put in input statements until the very end, and I certainly don't put them in my function. I keep them outside the function because the input is slow. It takes multiple steps to run it, then hit the input, and then switch to the appropriate window if it's out of focus. So I leave that to the very end because it makes testing quicker. Instead, I define my function. So mult table over here, and again, pass, that's just a placeholder. You don't bother copying that down because it gets deleted. Pass is what is needed by the function or by Python to say, basically, there's going to be something here. And this is indented properly. So just move on and stuff. And then I'll call it over here. Mult table. And if I want a 5 by 5 table, I'll call it over here. If I want to change it to a 4 by 4 table, I'll put a 4 here, same with a 3. But the point being is that I don't ask for the input until the end, until I'm done with the program, until I'm done writing it. It makes it a lot less work. And it's tempting to put that input thing in because you know it and you want to get down something. So here, what we're doing is that whenever we're taking in some value n, we're creating a new verb in the language called multiplication table. This verb doesn't work unless it has an argument of or something along with it by the name of n, which is just how big we want this to be. Now, what we do know we want 5 rows. Sorry, we want n rows. So if I pass in n, I want basically to be able to produce this vertical column over here. 1, 2, 3, 4, 5. In addition, for each of those columns, I want basically to count up by that number. 4, 8, 12, 16, 20. Right? This first one is 1, 2, 3, 4, 5. The second one is 2, 4, 6, 8, 10. This third one is 3, 6, 9, 12, and 15. So the question is, what do I want to work on first? Do I want to work on the rows or the columns? Because I'm going to need both. Any preferences to what we work on first, the row or the column? Okay. So the row is going to be as follows. We're going to do for num in range. Let's call it in, so for, and then we get into a naming thing, because really what we're doing is, now we said we're going to work on rows first. So why am I naming this column? Well, the reason is because when we go across a row, we go across by the columns. The first column, the second column, the third column, the fourth column, and the fifth column, right? So that's why, so whatever this column is, for range in 1 up to and including n. So in order to include n, I gotta not include n plus 1. And then I'll start out by printing, okay, I'll start out by printing just simply column. Okay, I'll delete the pass because I don't need it. I'll go ahead and put in 5 here, and I'm gonna run it. And as you'll see, what happens is that this goes by, is I can just run this by hitting F5 and boom. Well, that's not what I wanted, right? So one thing with print, and you may have seen me pause on this, is that when I was typing print, idle started being extra helpful when I hit this. And it says something all about star args, and then it said sep equals, end equals, file equals, flush equals. Ignore the last two right now. Remember when we do a print statement, we were able to do multiple things. Print is a function. I call it the print function multiple times, meaning it takes in multiple arguments. Print 1, 2, 3, 4, 5, 5,000. It takes in multiple arguments. These are all arguments. And it prints them together, right? Those are all arguments to the print function. Print is unique in the sense that it's got a special way that you'll eventually learn, but we don't really use in this class, where it says, I take some unlimited number of arguments. You can give me as many arguments as you want. All right. Then it's got a separate argument. This is a weird argument. It's got a name in front of it called sep equals blank, and it's saying, how am I going to glue these arguments together? And then end tells me how I'm going to end it. By default, it says, hey, glue my arguments together with a space and separate and end the thing with a new line. So if I modify this column, I can say, okay, how do I want to separate them? I can say, separate them for print I sep is equal to, I want to separate all this stuff with tabs. Oh. Actually, technically what we're doing right now, since I'm taking one argument, I don't use sep. I'm going to use end, because when I print, rather than ending with a new line, what I'm going to do is I'm going to end with a tab. End is equal to tab. Or you could do space, it's fine, but I like tab, as you'll see in a second, is that as that produces nice big results right over there. So rather than printing them out on separate lines, it doesn't, by default, this is what is implied when you don't have end. This is what's implied. This is what's implicitly done when you have no end, when you don't define end, which is the default behavior that you almost never have to do. In this case, we do. And this time we can override that feature and say, hey, I'd like to print out like this. I really like that about Python and with regards to how versatile it is. Okay. So that prints out an entire row. Okay. Now, let's move on to, so what I try to do when I'm breaking down a problem like this is I try to break down my problem into steps that are easier than the whole thing at once. I don't try to bite off the entire problem at once. Okay, so I've got 1, 2, 3, 4, 5 printing out once. Can I get it to print out 5 times like that instead? And that's kind of my next step. Can I do this 5 times, right? And the answer is I can. 4 in range, and we'll modify this in a bit, but 4 blank in range, well, it's n times right over here, right? So we just want this to run n times. And this is going to go through, this outer one here is going to be changed quite a bit. But the entire point is to be able to do an n by n table. Okay? So for blank in range n, this will run n times, which says to run this loop n times. So, and each time this loop runs, we increment it by 1. So what we get is, well, that's not what I wanted, right? Well, it's hard to tell from here, but it will be easier to see when I maximize this window, is that they're all technically on the same line. Right? Because my print statement over here said, hey, anytime we print out, separate it with a tab, right? Make sense so far? So what I'm going to do is I'm going to say, okay, so I've got this for loop. It's going to run however many times. And when it runs, it's going to print out these numbers in ascending order. And then and those numbers are going to be separated by tabs. And when I'm done printing out this stuff, I'm just going to print nothing to go to a next line. And there we go. Got 1, 2, 3, 4, 1, 2, 3, 4. Okay. So now what I want to do is that I've got each of these columns, 1, 2, 3, 4, 5. Now for the second row, I'd like it to be, I want it to be up count. So one way of thinking about this is that this first one counts up by 1s. The second column over here, or specifically, sorry, the second row over here counts up by 2s. This next one over here counts up by 3s. And this next one is by 4s and by 5s. So what I'll do over here is I will say, I'll say for row in range 1, 1 to n, right? Because we want to go, well, I'll just leave it like this and you'll see what happens. Oh, and nothing happens because all I did was just change the label over here, right? So now, but it's a multiplication table. You know, you have to, you know from having done multiplication tables at some point that you multiply the rows and the columns in order to get the inner entries. So row times column. Yes, this is the lab. So this first row is 0. The second row is goes up. This one goes up by zeros. This one goes up by 1s. This one goes up by 2s. This one goes up by 3s, and this one goes up by 4s. That's close to what we want. So again, what we need to do is we, instead of starting at 0, we want to start at 1. And if I don't add a +1 there, it's going to be like this, right? This only runs n minus 1 time, and I want it to run n times. And there we go. And now I can test this by changing this method call over here. I can change, and always, you kind of always want to test it to make sure it's not going to break. Like it looks like this one is breaking over here because I asked for 10 by 10 and this looks like it's not that. But again, what's going on over here is that word wrap is kind of on in idle by default. So when I make this bigger, we can see this works just fine. And if you're, and again, I work in a very large font size so that everybody in the back of the room can hopefully see it. And also because it prevents me from having to like strain like this, which is just does not work for the laptop I have in the keyboard configuration. It does not, it is not conducive for ergonomics there. So that works just fine. And now what we're done, now that we're done with this, we can find, if you're asking me, if I tell you to ask the user for input, we can finally put that in here. Okay, we can say, hey, we can say size is equal to int input, how big of a table do you want, or something to that effect. I honestly don't care what it's how it asks the question as long as it's asking it. And then we can say, and then over here we can say, and we can pass it in. And if we don't want to, use the user input, we can just comment it out over here and put in either a literal number, or if we don't want to run it, anything to run at all, we can just copy out these two things because we're done with it. I comment them out, not copy them out. So we can run this. Okay, and let's say, and I want a 5. And there we go. Now, one thing that I do see, or I have seen in the past, I actually haven't seen it this semester at all from any student who is demoing. But one thing that I do see a lot of time is something along the lines of this, where the idea here is that we want to take in I see this a lot, where you pass in a variable from outside the function, and then you immediately overwrite it. And this is because you think, okay, I'm writing a function's a subprogram, so all the parts go inside the subprogram. But the way these subprograms work, these functions work, is that they receive the necessary information to run from outside the program. That's what makes them a subprogram. And having this in here again, input slow down your testing. So you want to, if you asked it like this, we wouldn't need that argument being passed in first off. And I want you to get practice passing arguments. Second is, again, this slows it down. We don't want to do that. And third is that it makes it hard when it slows down like that. It makes it harder to reuse in a function, harder to reuse in something where we do want, where we don't want user interaction. Yes.
Confusing why you don't have to implement the variable size into
Well, so what happens is that we take this number, okay, and we store it into a box with the label size on it, okay, and then we pass it over here. Now you have two ways to view this, okay, two ways to do this. And I will get to your question in Zoom chat in a second. So this is kind of more the correct way to view it, which is literally what happens. We have a box. Say I put in size over here. We put it into a, oh, sorry, let's say I put in 7 for size, okay? It gets stored in a memory location. Think of it as a box labeled size, okay? When I call multiplication table and size, it passes this in and it copies it over. And so it's another box. Another way of thinking of it is, because this will get closer to the truth with ways Turtle works, because of the way references work and all sorts of nonsense, is that you can think of it as basically that this box gets another label on top of it. Okay.
Yeah, I didn't notice that, but size, that's the whole thing.
Yep. And sometimes you might just simply call them the same variable just to know that you want to line up the same thing. It's perfectly fine. I find myself doing that a lot, but for pedagogy reasons, I try to make sure to emphasize that those things don't have to be labeled the same. You don't have to name them the same thing. Now, with the turtle function, okay, so I'm going to go ahead and now comment this out because I've got this working. I can move on to the next one. So I had a question about so if somebody had this question about draw square, I've seen this a lot also as well. So let's go ahead and answer this question about draw square. The first thing I'm going to do is I'm going to import turtle, because for drawing squares, we need to have a turtle or turtle. And the question was, like, how in the world do these arguments work in this case? And it's the same kind of idea of these name tags, okay? Def draw square. Now, the draw square function here takes in 2 arguments. It takes in my turtle, whatever the name of my turtle is. It takes in also square size. And we can honestly make this, you can make this shorter if you want. You could call it T if you want to, or you could call it TURT for short. Just don't call it turtle. That'll get confusing because the package is named turtle, right? And what this function does, it's easier to see why we do it this way once I've written it. But what this function does is that we take a turtle from outside the program. So let's say, so again, gonna go ahead and do no. Okay, trying to autocomplete there. Very interesting. Pass. We're gonna do, and let's go ahead and move this up to the middle of the screen. Bob is equal to turtle.turtle to create a new turtle. And the entire point of draw square is that given this turtle, given a turtle in an argument, tell him to draw a square of this size. That's what we're providing there. We don't need to create a new turtle inside this function. What we're doing is saying we have a specific turtle that we're thinking about right now. Tell that turtle to draw a square. So what we do over here is that we can say something like draw square. So what we want this to do is draw square. This would tell Bob to draw square that is 50. And, has side length of 50. And so we do this by, okay, the variable name is my turtle. Okay. And we're going to spend about 5 minutes on this, not on the code, but like explaining what's going on here, because we got some good questions and I need to loop back to them. My turtle dot, well, we've seen how to do this. My turtle.fd, that's short for forward, square size. And I know I'm doing this out of order. Then we tell my turtle to turn right 90 degrees. And we ask the turtle to repeat that 4 times. For blank kin range. Yes, brotherhood there. For blank in range 4. We want to do this 4 times. Go ahead and indent this. Whoopsie. Accidentally hit the tick mark instead. So there, that will tell the turtle to draw that square. And it draws it. Let's go ahead and make it a bit. Let me go ahead and make Bob dot pen. What is it? Bob dot pen size. There we go, pen size. And then let's go ahead and make it 3. That should make it a bit easier to see, make it a bit thicker. And let's go ahead and turn that into a 150 per side because the screens are big these days, right? So we've got a Bob. So we've created Bob, pen size, and we've passed Bob into this function and gave him a square size of 150. This is where everything I just told you earlier about copying over stuff is kind of sort of a lie, because Python, C, Java, every programming language out there under the sun is passed by copy. We copy when we pass things into when we do pass things in, when we pass in. So again, we had a box earlier when we had a size and n, and we took the 7, we copied it over here. Okay, but when I do this, when I do Bob, and I have my turtle, right? And this gets passed into my turtle. What's in the box gets passed into my turtle, right? You know, it's a happy little turtle with a smiley face shell. Okay. We don't suddenly have 2 turtles, right? We have 1 turtle. What gives? I just told you that everything is passed by copy. So did we copy the turtle or not? Right? And I'll run it again just to emphasize the point. I'm going to move Bob. Okay, I'm going to move Bob forward 100 spaces, 100 pixels first, and then tell him to draw a square. And you'll see it is just 1 turtle doing all that. Move Bob forward, have him change his pen size, and then he does all this. It's the same turtle. What gives? And the answer is, for anything that's more complicated than a number, pass by number, this pass by copy thing is actually kind of sort of very interesting, which is that anything, right? If I store something in a variable, if I say x is equal to 7, right? What we do is we store the value 7 in x. But when I do this, when I create something more complicated than a number, be it a string, be it a list, be it a Bob in this case, what I'm doing is I'm not storing the actual turtle in Bob. This is a lie. I'm storing his memory location. Something like in hexadecimal. Let's call it 0xb for just simply because we can pronounce that, and it's valid in hexadecimal. That number, that memory address, is what gets copied into there. We copy where we find Bob. We copy where to find the turtle. So that's why when we're interacting with the turtle, it's the same turtle. That's why I say we're telling this turtle. And that's what I mean by Java is passed by copy, and Python is passed by copy, and C is passed by copy. Python and Java, they do this thing called referencing and dereferencing for you automatically, where basically it translates this stored memory address into the thing you want, and you don't even have to think about it. It allows you to be a bit more abstract. C is a pain in the tuchus because you have to manually get the memory address and dereference that pointer to that memory location, and that takes extra time, adds extra symbols, makes it extra difficult. To answer the question, how am I using Turtle? I imported Turtle up here. I just scrolled down. It wasn't on the screen anymore. All right. So, and the reason we can do this, and part of the other reason I do this is that I can create another turtle called Alice, right? And this is the last I'll say about this one. Turtle. Here's Alice. And then I can tell her, and then I can say Alice dot color is red. Alice dot pen size, let's 5. Alice dot right turn 90. So I'm gonna have her turn 90 degrees before I have her draw. And I'm gonna say draw square Alice 200. And so now what happens is that Bob draws his square, and now Alice draws her square. Two different turtles, they're able to use the same command. They can use the same command and reuse it for each turtle. Now, when you finish up draw row, what we would ideally want you to do is, rather than like recreate this entire thing for drawing a square, we'd really like you to, draw the row. And if you're not finished with draw grid yet, my hint to you is that for draw row, for all these turtle functions, in fact, it's much easier if the turtle ends where he started. It makes your thinking a lot easier when the turtle makes a round trip. Okay. Any other questions on the homework? Again, I know that for loops and these nested for loops are stumbling blocks. Part of the reason that I like this particular exercise of drawing the stairs and drawing the grid is because you are still dealing with nested for loops, but the nesting is hidden because you're doing function calls. Right? Those are just for loops inside for loops, and we're just simply hiding that. Okay. So again, what I can do here is I can comment it out. And let's go ahead now and open up. I'm going to go ahead and open up Canvas. You can find this under our Canvas. I uploaded it today for today's in-class exercise. So we're going to go over some new problems today. Well, new to you. I've been doing them for a bit. Okay. Assignments. So you can find them under assignments. It's the loop and function exercises under module 6. I have a due date for them. The due date's actually not a hard due date. I just realized, wait a second, it will show up on your upcoming exercises if I put a due date in. So that way it's easier for you to find. So that due date is soft, just like all the other in-class exercises. So you can find it by clicking again over here under the in-class exercises, or under module 6 by clicking on the loop and function exercise. And I even say over here, I'm checking it for completion, not for correctness. No need to demo it. It's done. It was done in class today, so you can refer to today's lecture to do that. All right. So there were 4 problems on here. Some of them came from a Java textbook by an author called Savage. Now over here, what we wanted to do is that we're doing the same thing, but with a twist. We are returning instead of printing our answers. Okay. We don't want to, we're going to be printing what we want outside the function. We return the value. The difference is that when you print out something, that's useful to me, the user. It's useful to the person doing the programming. It's useful to the person who's reading out the text. It's not useful, though, to other parts of the program who might want to use that answer somewhere else, right? If I have a function called calculate necessary velocity, and it figures out the velocity, I might want to use that number somewhere else rather than printing it out. I might want to use that necessary velocity and not have to manually plug it in after running it. So returning basically so with functions, the arguments serve as your input and the return value is your output. Now, sorry, The issue is here is that I'm going to tell you a lie, and it's a lie no matter how I say it, because I can tell you that Python can only return one thing. And that's a lie because you can return multiple things in Python. But that's a lie because technically what it does is that it packages up all those things into one thing, and it returns one thing, except it will automatically unpack it for you if you ask. So the answer is that Python's really flexible with returning stuff, more flexible than other languages. Other languages, you have to you can only return one thing. Python, if you want to return multiple answers at once, it allows you to do so in a much more easier and understandable to read format. You won't need to use that for this class, but for other classes, you might. And so let's go ahead and look at these problems. So the first problem is number of vowels. Write a function which, given a string, returns the number of vowels that were in the string. So we feed the function, we want a string as a parameter, and then we return an integer. The second problem is the number of even digits. I like this one because there's two really different ways to do this one. In other words, given a number, tell me how many even digits are in it. And then number three, the 3-digit Armstrong numbers. Armstrong numbers are these numbers where if you separate them, each digit if you separate it into the individual digits, like 371 into 3 and 7 and 1, and then you cube each of them. In other words, you know, 3 times 3 times 3 plus 7 times 7 plus, sorry, times 7 plus times 7 times 7 plus 1, then it adds up to itself. So 371 is equal to 3 cubed plus 7 cubed plus 1 cubed. 370 happens to be right next to it. So those are 3-digit Armstrong numbers. Pretty cool thing. And so we want to write a function that checks that's the case. And our fourth problem is something that I grabbed from Savage's textbook, which says, hey, go through and find a number of these that mentions the criteria of this problem. All right. So let's go ahead and take a look at the first one and get that set up for you. So the number of vowels, I'm going to go ahead and name that def num vowels. Given a string, I'll go ahead and call that word, because even though it's a string, technically we're most likely going to get a word. If you want it to be more abstract, but not necessarily call it string, you could call it text. That's my other go-to for strings for variable names. So, but we all go ahead and call it word. Num vowels in the word. And what we want to do there is that we want to iterate over, we want to count, we want to figure out how many vowels there are. So our count is equal to 0. And then at the end of, and then we're going to do stuff. And then at the end, we are going to end the program by returning count. Okay, when we're done, we return. An important thing to know, especially for beginners when dealing with return statements, is that returning ends a function. So if you return in the middle of a function, it doesn't matter if there's stuff elsewhere in the function, function's done. We got an answer, we should give it back. No need to do any other calculation. So, and now what we can do is that we can say, hey, we can say print num vowels, and we can give it a word like hello, which should have 2 vowels, but right now it's going to print out 0 because all we do is declare count is equal to 0, and then have a comment telling us to do stuff and then return it. So for this one, what you want to do is iterate over this word, check every character, see if it's a vowel. If it is, increment count. And again, there's a lot of ways to do that. With your if state, and your vowels, of course, are A, E, I, O, and U. Sometimes Y is a lie. It's only A, E, I, O, and U. Those are your only vowels in English. So those are the only 5 you have to check for. So I'll give you a couple minutes to work on this one. And if you finish that one before I come back here, feel free to work on the next one. right now, we can assume they're lowercase. So for right now, you can assume it's lowercase, you don't have to worry about capital letters and stuff like that. We'll talk about that in a second. All right, so gone over this with a couple students. So there's about two primary ways to slice this problem. Okay, although it doesn't use slices, so I guess. All right, so what we do, so there's two ways to do this, but they both primarily rely off of using the for loop, for letter in word. I love Python because it allows me to write things that actually kind of make sense in English. For each, so remember, these loops are kind of are called for each loops, for each letter in word. What do I want to do with that letter? I want to check if it's a vowel. How do I check if it's a vowel? Well, our two big ways are, the first is the most direct way, which is if letter equals A, or, and then we just simply copy paste because E or, and now you see why I said assume lowercase, because otherwise I'd have to do this twice as long. U O I. So if the letter is an A, or the letter is an E, or the letter is an I, or the letter is an O, or the letter is a U, right? If that's the case, then what I want to do is that I say count is equal to count plus 1. A very common thing you might write, or you might feel obligated to write this, is like something for an else statement where you say count is equal to, well, in this case, you're not really sure. You don't want to say count is equal to 0 because that would reset the count. You might feel obligated to say count is equal to count, or count is equal to count plus 0. But whenever you have an if, you don't need an else. The else can just not exist. You're allowed to not have an else. So for letter in Word, if the letter is an A, E, I, or U, you can do that. Now, the other way that is more, there's the other way that's concise in Python is that you can use the in statement like we did last week. Or not last week, it felt like last week, last Tuesday. The in statement to ask if the letter is in something, if it's in a list. So we could say something along the lines of, if letter in, instead of doing this, I'll write this up here. I'll say all of our vowels are, I'll make a list of all our vowels. A, E, I, O, U. Yes, if you're about to ask, you can do this as a string. Yes, you can. I'll do that next. Vowel. So if letter in, let's call it, actually, let's call this vowels because it's plural. So if your letter is in vowels, and I'll go ahead and move this below the comment because that makes it a bit easier to read, in my opinion. So if the letter in question shows up in this list, then increment the count. Okay? And for either case, if we run it, we should get 2 now. But there is even one more concise way to do this because we're working with strings. Alternatively, instead of declaring val as a list of strings, we could just simply say, since we're choosing one letter, we could do A, E, I, O, U as a string. And that works equally as well. Python's fairly expressive like that. Now, I did mention not to worry about capitalization or to assume everything would be lowercase. So if we do that, though, then if I run this, this breaks, obviously. It doesn't do what we need to do. It doesn't count the E and the O, the capital E and capital O, because they're not an A, E, I, O, or U. We have 2 ways to fix that, which is that we can put in A, E, I, O, U capitalized, or the other thing we can do is that we can say word is equal to word dot lower. Okay. So when you ask what lower does, the person will typically say it makes the string lowercase. It turns all the letters lowercase, which is an easy enough way to think about it. But there's an important thing to remember about strings. Strings are immutable. That means anytime you would normally think about making a change to a string, like turning all the letters lowercase or changing one letter out for another, technically what you're doing is you're making a new copy of the string where that change has taken effect. So what I did is I created a new string where they were all lowercase, and I stored it in the word box, in this box, instead of hello. Okay. Semantics, but it's something to think about later. It's why if I do it like this, it's not going to work. Yeah, that's why I have to store it in, I have to take the new string and store it in Word. But now this works. Which one is easier? It's up to you. But again, it's all expressive, and a lot of things are a lot easier to deal with if you just simply, you know, change the number, if you change the string. Okay. Yes,
Why don't you parentheses after the word before the four-letter name?
this thing, like that.
Yeah, where should you do that?
No, word is you only use functions if it's you only use the parentheses if it's a function call. And basically, if you're trying to run a verb, and word in this case is a noun, we don't need it there. Okay. So now for the next problem, which was def num even digits. And we take in a number. So we're going to assume here that the number is a number, and it's going to be specifically an integer. Okay. And again, it's kind of the same idea. Count is equal to 0. Return count. We return the number of digits that are even. Now, there's two ways to approach the problem. The first is to do some math, and the other is to iterate over it. Doing some math is the more efficient way to do it in terms of like actual what the computer cares about, efficiency in terms of time. But a lot of times students find it, especially if you're beginning, find it a lot easier just to iterate over this. But this is another kind. Now, the reason I bring this up is because you think, okay, so num even digits. Okay, my digits are, my evens are, you think, okay, I'll do the same as the next problem, as the last problem. Evens are 2, 4, 6, 8, 10, right? And then you say for D in number, for each digit in the number, if D in evens count plus equals 0. Now, the cruel thing about this is that the logic is completely correct. The logic is correct. The implementation is wrong. We run this. And if I say num even digits on in this number, I expect 2, and what it gives me instead is a big honking error, which is definitely not what we want. It gives us a type error. It says line 59, which in idle, it's a bit hard to see, but the line you're on, you can edit idle to have the line numbers right here on the side. If you don't do that, like I haven't, the line number can be found right there in the circled area. But line numbers, turning them on can be useful. Let me go ahead and see where they are in Python or in idle configure. Let's see, Windows. Does it have it in here? Highlights, built-in theme, extensions. I know there's something to show line numbers. I'm gonna spend like 5 more seconds on this before I give up. Run options. Oh, right over here under options, it says show line numbers. There we go. So it can be helpful very helpful for debugging. So it says line 59. Int is not iterable. I'm going to turn off the line numbers because it makes it a bit easier for writing the code, even if it does make it hard for me to debug. But I know where to look for the line number. Line 59, 4D number. What this is saying is that a number is a number. You can't iterate over a number. It's a number. There's no part of this which we've had an entire fight about this, about how to iterate over like you think, okay, if you want to iterate over numbers, that should be doable because you would just go from the biggest to the smallest digit, right? No, we've had a huge fight over this. Big, and it's fun, it's got funny names too. Big endian versus little endian. Which you can find in endianness, which is to whether or not you should order things from biggest to last or last to biggest in computer memory. It's an entire fight and it's annoying. So So when there's some level of ambiguity like this, right? Python can't give you the least surprising option because there's valid arguments to be made. And it says, besides, it's a number. It doesn't really make sense. So what we do instead is that we, if you want to do it this way, we need to make two changes. I'll make one first, which is if I want to iterate over this digit like you think you should, oh, interesting. That is very interesting. It's an interesting Pokemon fact and relevant. Anyway, so you think, okay, if I want to iterate over this, I'm going to go ahead and turn this into a string. And that will give us a, I think, let's see. So print. And this will not, and as you can see, we don't get a runtime error anymore, but we do get a bug now because we should be getting two, this number has two even digits, the 2 and 4, but it doesn't detect that. Because, it's comparing the number, it's comparing the string and asking if the string 2 or the string 5 or the string 3 is in this list of integers. So we have one more thing to do there, which is that we can convert this int, this string, back into an integer over here. That's one way to do it. Or we can just simply say, okay, we're converting the entire thing to strings. Right? We're converting the entire thing to strings, so might as well just give up and make the entire thing strings. 2, 4, 6, 8, 0. Technically it wasn't 10, it was 0. Okay, boom. Right? That's the way to do that via this. I'm gonna go, since there's only like 24 minutes left, I'm gonna give you a bit of time to work on this one, and then I'll work on the next one with you. But this is like the least efficient way, or the less efficient way to do this in terms of memory, because you're converting it from one to another, and instead you could use math. Okay? Now, how in the world do we solve this using math? So we have two tools at our disposal here to use math. And they are the modulo and the division. Okay? Now, first, if I do something like, specifically modding by 10 and dividing by 10, okay? If I say x is equal to, and I'll give you these two tools here, and it's up to you to figure out how to use them. X is equal to number mod 10. What that asks, what is the remainder after dividing by 10? But the answer it gives you is it's the last digit. It's the ones place. This gives you the one place of your number, right? This gives you what the last digit is. Modding by 10 gives you the last digit of a binary, of a decimal number. Okay, gets last last digit. Next, we have x. Sorry, now I have number is equal to number divide 10. This will discard the last digit. If I do this operation on 23,574, it becomes 2,357, right? This gets the last digit and stores it in something else. This just discards it, okay? Now, the last key ingredient, which I'm not writing, is not using a for loop, but instead using a while loop. I mean, you could use a for loop here. You just have to figure out how many digits are in this by again, converting it to a string is one way, or dividing by 10, but you're already doing that. So the way we figure out how many digits there are, so what you want to do is use a while loop. And since we're discarding numbers, you want to keep discarding numbers until basically your number is bigger than, while your number is bigger than 0. Keep discarding your digits while your number is bigger than 0. So go ahead and take a couple minutes to try to do that. You can run multiple functions in one file. Yes, you can have multiple functions in one file. You can have as many functions as you like in one file. In fact, it's a lot more convenient that way. All right. All right. So now let's see how to use these tools, and we're going to use them in the next couple of problems. Again, it was just a short time because we only have 20 minutes left in the class, well, less than 20 minutes left in the class. I want to make sure we can hit each of these problems. We can go back and review them as you need. So for num digits, going to go ahead and doop, 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 doop. Okay, so again, what we're going to do is we're going to say count is equal to 0. Return count when I'm done. And what I'm going to say is I'm going to do a while loop. While a condition is true, it's going to run. So while, and this is probably what you were missing, while number was greater than 0, we want to do this. So what we're going to do is we are going to so while the number is greater than 0, what are we going to do? We are going to get the last digit. Last digit is equal to number mod 10. And then I wanted to see, and then what I want to do, I want to check if it's even, and then I want to discard it, that last digit. And I discard that last digit by saying number is equal to number, divide 10. And it's important to use divide because otherwise you're going to just start getting decimal places, and that's not what we want. We want to toss off the last digit. If you forget to put this in, this is one of those places where you might run into an infinite loop. Okay. Last digit is equal to number mod 10. So now we check if that last digit was even. If last digit, and the way we check if something is even, it's also modular arithmetic. If last digit, if we divide that by 2 and end up with a remainder of 0, so if last digit mod 2 is 0, then that's an even number. Right? So that's what this one comes out to. So while we have a number greater than 0, the last digit is, we get what the last digit is, we check it, increment by 1 if it's even. Last digit is, it's even if you divide by 2 and the remainder is 0. And then we discard the last number. So here we pass it in our old value and we still get 2. Now you could make an argument for an edge case of 0. That's kind of trivial to solve. You have an if statement if it's 0, but I'm going to move on from this one. And let's see. I should be able to like drop this file into Discord after class. So if need be. Again, but even if I don't, this recording will be here for you to look at later. All right. Next problem is Armstrong numbers, which I'll start off by writing over here above it. So if you're still copying down the previous one furiously, I can just write it. Is Armstrong. So again, an Armstrong number is a Armstrong. An Armstrong number is a number, again, we're being passed an integer, it's a 3-digit number. We can assume it's 3-digit. And what we need to do is we need to break it into, what we do is it's a number where if you take each of the digits and cube it, it's equal to your original number, right? So again, going back to our example, the Armstrong number, two Armstrong numbers that happen to be right next to each other are 370 and 371. Those are Armstrong numbers because it's 9 plus whatever 7 cubed is plus 1. So in that case, it would be 361, I guess. 361. So is Armstrong number. So what we have to do here is going to really help us in for the next program, which is that we need to, is that we could do it like, is that we could take this one over here and have a running total. So we have total is equal to 0. And we solve it like the last one, or that's one way to solve it. What we do is we say, while number is equal to is greater than 0, we get the last digit. The difference here is that we don't have an if-else statement here. The difference here is that we want to do a running sum of the cube of the digit. When we ask ourselves here is, we say if total is equal to, we don't do an if statement, we just simply say total is equal to total plus last digit cubed. Make sense? So we have a total over here. Sorry, we have a total over here. While number is equal to is greater than 0, we check the last digit, we cube it, add it to our running sum, and discard that last digit. Now we have an if-else statement. I mean, you don't need to. I'll go into that in a second, but we can basically say, hey, if total, what I was going to do is ask if total is equal to number, but that's never going to be true. Why? Because I destroyed my original number by discarding the digits on it. Remember? I did that. I totally did that. Okay, so let's go ahead and instead, I'll go ahead and say original origin is equal to number. Copy it in. if total is equal to our original, return true. And there we go. Else, return false. I often forget to capitalize this because in other programming languages, it's lowercase. It's no biggie. The interpreter or editor that you're working in the respective language will let you know that you typed it wrong. It's not even something, if you mix it up on an exam, I'm not even going to care about it. I might not even notice. Okay, it's that trivial of a mistake. It's one of those instant fixes if you're using this. So now, my number is this, divide this, total is equal to origin, return true or false. Okay. Alternatively, since we know it's a 3-digit number, we could split it. We could individually use mathematical operations to get the ones place, the tens place, and the hundreds place. But I'm saving that for this problem, which is why I sped through this one over here. The Riddler problem, one of my favorites that I used to give out as a homework. Now we're doing it in a 10-minute exercise. Holy digits, Batman. The Riddler is planning his next caper somewhere on Pennsylvania Avenue. In his usual sporting fashion, he's left the address in the form of a puzzle. The address on Pennsylvania is a 4-digit number with the following properties. All 4 digits of the number are different. The digit in the thousands place is 3 times the digits in the 10 place. Our number is odd, and the sum of the digits is 27. Write a function that uses a loop or loops that returns the address where the Riddler plans to strike. Okay. So essentially what we're doing is that we're looking for a 4-digit number where these 3 clauses are true. Now this one, unlike the other ones, doesn't take an argument. We're searching for a 4-digit number where this is true. Def Riddler takes in no arguments. And we need to loop through all possible 4-digit numbers. We need to check all of them until we find the correct one. That means that we need to write a for loop for number in range, except we can be a bit clever with our range here. We can only go, we only want to consider 4-digit numbers, right? So we can start at 1,000 and go up to, but not include 10,000. Furthermore, we check our conditions. All 4 digits are different. The digits in the thousands place is okay. The number is odd. Now we could normally just figure that out by just doing a divisible by 2 test, but we can skip that entirely by being clever with the range we're going over. We can say, let's start at an odd number, 1001, and then we go up by 2s. And that prevents us from doing yet another, from having a check in there that we don't need. Now for these other ones, these other 3 clauses are annoying. We have to do all 4 digits are different. The digits in the thousands place is 3 times the digits in the tens, and the sum of the digits is 27. So all these rely on checking what the individual values of the digits are. So we have to figure out all of those places. The thousands, what is the thousands place number? What is the hundreds? What is the tens? And what's the ones place? Task. So we got to take our number and do some sort of operation on each of them to get our tens, our ones place, our tens place, ones, tens, hundreds, and thousands. Now the first and last are actually not that bad. We know how to get the last digit of something. You mod by 10, right? To get the last digit. We've been over this a couple times in the past 10 minutes. Okay. Similarly, it's fairly straightforward once you remember how integer division works in programming to get the thousands place, right? If I give you this number and I ask you to divide it by 1,000, it gives me the thousands place. it's fourth grade arithmetic, right? It's just simply four quotient, 4 is our quotient, 293 is our remainder. What we do here, another way to look at this is that we discard the last 3 digits, which might be useful for us later. But here, all we have to do is just simply to get the thousands place, we can simply divide by 1,000. Now, we can't exactly use the same logic here. 100, you can't go, okay, divide by 100 to get the hundreds place. But let's think about that. What happens if we do that? Okay, I want to get the hundreds place of this thing. If I divide 100, the quotient it gives me is what? It gives me 45 as the quotient, 36 is the remainder. We don't care about the remainder, it's just 45 left over. But I know how to get but it gives me 45. That's not the hundreds place. What is the hundreds place? It's 5. How can I get the 5 out of this thing? It's the last digit, mod by 10. So divide by 100 to get rid of the last 2 digits, mod by 10. Similarly with the tens place, sorry, that was wrong. I had 1 extra 0 there. 45, so 45 divided by 100, sorry, 45, 36 divided by 100 gives us 45. Mod by 10, that gives us 5. Similarly, 4, 5, 3, 6. If there's 2 ways to look at this. I divide by 10, and and I get 453 is our quotient, 6 is the remainder. Or remember how I was describing it up here, dividing by 10 is the same as chopping off the last digit. And then again, the tens place is what we want. That's right here. It's the tens place happens to be the last digit. So we mod by 10 again. Number, divide by 10, mod by 10. Now, you might be thinking, wait a second, what's the order of precedence again for modulo? Does modulo occur before or after? Because modulo, if you remember, if you're taking any modern algebra classes at some point, that can really kind of throw you for a loop. You think it should go earlier than it does. Modulo is the same because it deals with remainder. It's the same thing as division, integer division, multiplication, and itself. It's the same precedence as all of them. But what should you do if you can't remember what precedence things are? Use parentheses. If you can't remember and don't have time to look it up because it's an exam or you're going fast, just use parentheses to say what you mean. And it might help you later when you read it, because now we know what the intent was. So now we have our digits. So now we basically have to check if they are different. If ones, so let's see, if thou is, so this part is a bit annoying. If thou is not equal to huns, a bit of a long if statement. Thou is not equal to If the properties are all, if the properties are all equal, that means it goes from left to right. Thou is equal to huns is not equal to that, and thou is not equal to tens, and thou is not equal to ones. These and thou, I thought, not religion class. All right. Okay. Huns and hund is not equal to tens. And huns is not equal to ones, and tens is not equal to ones. And those are now, okay, so that was a long line, but notice what I didn't say. I didn't say if I did thous not equal to huns, thous is not equal to tens, thous is not equal to ones. And then I said, I didn't check if huns is not equal to thou. I didn't check if the hundreds place was equal to the thousands place. because I've already checked it. I checked if the thousands place was equal to the hundreds place. You don't have to double check it. It's the not equals is reflexive. A not equals B is B not equals A. It gives you the same result. So thou with the huns, tens and ones, huns with the tens and ones, and then tens with the ones. All right, so that checks if they're all different. Now we can have another if statement below here. If the digit in the thousands place is 3 times the digit in the tens place. Okay, if 3 times tens equals thou. And then finally, if the sum of all the digits is equal to 27, if thou plus hund plus tens plus ones, print the number. Which, if we run this now, and I'm moving quickly because I'm out of time. Riddler. Invalid syntax. Where did I miss these? Where? Oh, right, because this is nonsense I wrote over here and it didn't come to out. Oh, puns. Wow. Okay. Yeah, consistency. Not me, apparently. Hund. Thank you. Yeah, I will say in my defense, typing and talking are really hard. Okay, so that's a bit too many. If thou is not equal to one, huns. Oh, right. Again, talking and typing here. Talking and typing here. So the answer would be 9,837. 3 times this is this. This is 27. It's odd, and all the digits are different. It fits our criteria. All right, with that, I need class is over. Well, it was over a minute ago. I cannot, unfortunately, meet after class today because I immediately have to go into a graduate admissions meeting right now. So if you need to meet with me, send me an email. I will do my best to meet with you over the weekend. Yes.
Demo, right?
Yeah, there's no need to demo this, just simply upload this. All you have to do is upload this like you would an assignment, but again, this is checked for, did you actually, like do something? Did you submit something? I don't check to make, I check it to see, did you participate? It's for participation, not for like correctness, right? Oh yeah, I'll drop it on Discord.